Hello and welcome to the final video on my quad motor tailsitter airframe. Now this might be labeled as the last video, but this does not involve success in the way that you would imagine it. This is also the presentation I am making for my class. So this is the video that my professor will be seeing. So I'm not hiding anything, I'm giving the whole picture. But despite failures, that I'll go over here in a minute, I consider this project to be a success. So my goal with this project was to build a tailsitter VTOL that could be disassembled and reassembled in the field easily and would be simple to use and have the capability to have a payload mounted to it. I have hit the mark on almost all of those except for the flying part. And if I haven't flown it, and if it doesn't fly, why am I considering this a success? I'll go over that in a minute. First, I'm going to show you why it's not flying right now. So the reason this isn't flying is because of a very specific and kind of unique problem that I've got. Let me plug this in and it'll make sense. Now, the explanation I have will be in a sound that those motors make. So when I plug this in, listen carefully. Hear that? Let's hear it again. Now obviously I can't just leave it at that and not explain why that is a problem. So, here goes. The noise you heard is the startup noise for that flight controller that it makes through the ESCs and motors. Basically, it takes the frequency of the motors and adjusts that frequency and vibrates them back and forth to create sound and noise. And it will do that in playing a melody. Now, the stock startup sound is not, in fact, the sound that drone made, meaning those ESCs have been custom configured before. I didn't configure them. Normally, that's not a big deal. But the problem is, the guy that I got the ESCs from, like I said in my last video, is kind of a genius. He codes drones, builds custom firmware from scratch because he feels like it. Yeah, you will know him as Quick Flash. He won Terrence Howard's linchpin drone competition. He's also the lead developer for Emu Flight. And the reason that's kind of problematic is I suspect that these ESCs are running D-Shot, which is a kind of protocol for ESC communication. Normally you have a pulse width pulse width modulation signal, which basically you're making a box like this that gives you this number from the top of the box to the bottom of the box, and that's your frequency. Your flight controller or your ESC will read that frequency. It says, okay, if I'm at this number, I need to spin the motor at this frequency, which is related to it. It's complicated. I'm not going to get into that here. However, like I said, these ESCs are not running PWM, they're running a protocol called D-Shot, which is a digital protocol, meaning that the signal that those ESCs are getting from the flight controller are not pulse width modulation signals. It's a digital signal. And this flight controller is an F405. And F405s are not super high-powered flight controllers. There's a lot of modern things you can do with an F405, and it'll do great. Like, it'll do the speed tool no problem, it'll do multi-rotors no problem, it'll do fixed wing no problem. No worries. The trouble is that they struggle with D-Shot. Now, normally you would say, okay, but you can just upgrade a D-Shot and it'll fly a fixed wing just fine, right? Yes. However, this plane is not a regular airplane. It's also a quad plane, a tailsitter, a VTOL. So this has to do both multi-rotor and fixed wing operations, which takes some processing power. And because that takes extra processing power, the flight controller CPU does not have the bandwidth to also use D-Shot. Now, for those of you who are experienced building drones, like my professor who will shortly be watching this video, You might say, well, can't you just flash the ESCs to a PWM firmware? Yes, I can, and I might eventually on this flight controller. However, due to the way this F405 SE is set up, it does not like to fly. As you can see here, is soldered to the underside of this flight controller. Flash the firmware, resolder my receiver, try it out, and if it doesn't work, reflash to a different firmware after again desoldering my receiver, and then resolder after the flashing, and then rinse and repeat. And that's a process I really don't have time to do. This is the last possible day I can turn in this assignment, being this tailsitter. Now, normally this would be a failed project since it hasn't flown. However, it did hit several marks that I find to be a success. First off, it is a relatively simple airframe. I got the plans for this for free, and I was able to cut out the plans from foam board and glue it all together in less than a week. That's a built airframe ready to go that, needs to be modified for VTOL, but can just fly out of the box. So it's simple, and it's disassemblable and reassemblable in the field with just a screwdriver. Meaning, theoretically, you could break this down and fit it into a large Pelican case to take out to the field, which means that it's also fairly easy to put onto an airplane and take across the country, fly missions, what have you, which is a lot easier than the large boxes I have had to haul around for flying 10.5-foot wingspan VTOLs. Another success is that the ELRS telemetry works. Not very fast. My professor was telling me that there's some settings I can change on that to make that work better, but it works. I get a solid connection to my aircraft. I'm able to control the aircraft over ELRS. I was able to mess around with some servos and get them to work. And so the system works. I'm able to control it over RC, and over that same RC link, I'm getting MAVLink to my ground control station, which means that there's less hardware I need to buy, and it's a far simpler electronic system. Plus, this is my first time ever configuring a tailsitter, and I had to go off of the ArduPilot documentation, which, like I said in my last video, there are hundreds, if not thousands, of pages of documentation that you can go over on this stuff. And so the fact that I was able to read those instructions and build one from scratch without any extra instruction, I think is impressive. Because even though it doesn't fly, it goes through the flight modes. I'm able to set it into Q stabilized, and the gyro wants to point straight up. And when I flip it into fly-by-wire A, or fixed wing mode, it wants to flip forward. So recognizing those flight modes is farther than I've ever gotten on any other project that I've wanted to do. Because there's another tailsitter that I was doing a custom firmware for that did not work because I could not get past that roadblock. And yet I have here. Along with that, there's a lot that I've learned. One of those things is time management. I really, really, really need to work on my time management for this. And I learned how to do it by the end of it. But by the end of it, it's too late to really fix stuff. So I really struggled with time management at first, and I figured it out partway through, and then things kind of went to pot schedule-wise. But I learned. Obstacles I didn't anticipate. I didn't anticipate having to wait so long for parts to get here. I thought I would be able to glue this up and be pretty easy, and then be done in like 2 weeks and just spend most of my time flying. Obviously that didn't happen. Another roadblock I didn't expect was how hard it was to modify this airframe to be a tailsitter. See, it wouldn't have been so difficult if I was just making it a tailsitter. But because I wanted it to be disassemblable and reassemblable, it was very difficult because I had to line up my spars and make sure everything was on the same plane, and a bunch of design consideration. If you look at that landing gear over there, that's flat on the ground, right? That's not moving anywhere. If you look at this leg, that's not on the same plane. Which means my wings are set at 2 different angles. And if I had tried to hover this, or fly this in fixed wing mode, it would corkscrew and crash, die, burn, possibly explode, end the world, etc. So, I've learned. I did get my goal of this being able to be disassembled, but it's not easy to disassemble, and it ended up making a failed airframe because, along with all the electrical problems, I would have to completely rebuild this from scratch to get a flying aircraft. So that's not happening. Now, the reason I wanted to do this project is I've never done this before. And I figured, hey, I'm sure I can do this, right? It can't be that hard. I work with quad plane VTOLs all the time. I build those for a living. This'll be fine. It wasn't as fine as I thought it would be. There's a lot of success, but like I keep saying, it didn't fly. So, as far as this relates to what I want to do in the future, this is, like I keep saying, it's a really good learning point. So I chose this because it was a challenge, and even if I failed, I knew I'd get something valuable out of it, which I failed to fly, but I've learned and had a lot more success. Now, as far as this relates to my future career choices, this is what I want to do for a living. I want to build and design aircraft, ideally VTOLs, and sell them. I want to be working for a company to design and build these things and have success in the field and add to the industry. So that's where I want to go long term. And so I figured doing a tailsitter was the best way to get there. Now, I know I keep saying I've had some successes, but I did fail to fly. But I think my biggest success out of all of this was configuring the flight controller on my own and getting Mavlink to work over ELRS. So the flight controller, I've configured flight controllers before, but I've always had somebody looking over my shoulder and giving me pointers on how to do that. I didn't have that this time. I could have talked to my professor and have him walk me through the steps, but I purposefully decided against that because I wanted to push myself to learn how to do that. And with the Mavlink ELRS, I got that to work too, and that's another major success. Again, I tried to do that on my own so that I could learn on my own how to do these things. And so even though I'm not close to where I wanted to, well, I am close, but I didn't get to where I wanted to be as far as this project, having a flying VTOL that can have a payload mounted to it, I am at a point where I consider this to be a success because of how much I've learned from it and how much I'm going to be able to succeed on the next build. Because I do plan on doing another build. Because this one failed and I would have to basically rebuild the entire airframe, I've decided I want to do a different design of tailsitter. Now my professor is working on a tailsitter very similar to the one I want to build, but it'll be a 2-motor tailsitter using a KF, step, wing, etc., etc. I have the airframe that's already built, so that entire half of the project is done. All I have to do is mount a flight controller, possibly this one, and make it fly. So that's my next project, and that might be one of the things I make videos on next. So, thanks for coming along for the ride. Sorry I didn't get to show you a cool flying aircraft, but hopefully we've all learned something along the way. Thanks.